Hello class, today's tutorial is going to be on using StatCrunch to solve common questions using one sample t-tests. Okay, so first this is an example homework. I am looking at question number 3 here, and it has an interesting claim where 12 a.m. body temperatures believes that the mean of body temperature at 12 a.m. is greater than 98.6 degrees Fahrenheit. They collected some data on a sample size of n equals 9, and they calculate a test statistic of 1.531. Find the p-value. So before, what we did was to find the p-value was that we had probably the mean, the standard deviation, and the number of people, and we were able to calculate the p-value using the summary data. We don't have that here, but we do have the test statistic and we have the number of people, and that's more than enough than what we need to be able to calculate the p-value. Let me show you how. So first I'll close this just for simplicity. I'm going to go back, open StatCrunch, opens up in a different window. Here it is though. I'm going to go Stat, Calculators, T. Okay, and now I'm going to make sure that I update all the fields here so that they're accurate. So the claim is that it's greater than. That's the first thing I want to do. It's going to shift it all to the right. And now what I'm looking at is a sample size of n equals 9. Now in degrees of freedom terms, that's what I'm going to be putting in here. What I'm actually going to put in is 8, because the degrees of freedom for this test is going to be n minus 1. All right, now I'm going to put in the test statistic here, which is 1.531. Compute that. I get a p-value of 0.082. Round the 3 decimal places. 0.082. Check answer. Well done. Going on to the next one, looks like this is the same. Okay, now all that you would have to really be able to do here is make sure that you, one, change this because it's looking for less than, update this because it now has 50 people, and then put in the test statistic, which is minus 1.524. Compute. Okay, gives me this is my p-value, p. So this is basically saying p-value given some t statistic, and this is the t calculator. Then that's how you're going to solve it. All right, moving on to the next one. Okay, now we're getting into specific things about claims and really trying to look at our null versus our alternative hypothesis here. So the first part of this question is determine which of these alternative hypotheses is the one that this claim is actually testing. And so if you can eliminate any option here that has a null hypothesis that does not have an equal sign for it. So this one I already know that D, that is not the correct answer, so I am left with A, B, and C. So we just have to look for if the claim is greater than, less than, or not equal to. So we just kind of skim through here, measure 159 adults. The stats unit claims the population of adult males has a mean platelet count greater than 225. I'm going to select C. Great answer. Okay, now I'm going to identify the value of the test statistic given the data that it's given me. All right, so what do we have so far? We know that it's a significance level of 0.01. That's not going to change anything, but it's something we're probably going to have to pay attention to in the future part of the question. So we have, it already gives it to us here, so we don't have to calculate anything. You just click on this I, and it's going to give us a kind of technology display, or basically the results of the statistical test ahead of time, so that makes it a lot easier for us. So identify the value of the test statistic. We know that this was a t-test. Here's the t. Here's the test statistic, 0.92. Easy. Check answer. Good. Now I'm going to identify the p-value, p.18. Check answer. Well done again. And now it's going to state the conclusion about the null hypothesis as well as the final conclusion that addresses the original claim. We're going to probably say failed to reject the null. There's not sufficient evidence to support the claim that the population of adult males has a mean platelet count greater than 225. That one sounds the most reliable, the failed to reject. So we are going to say that the mean platelet count is equal to. And if we already look up here, that's exactly what our null hypothesis is, because we failed to reject this. We were unable to accept this. So we're going to say that it probably is close to equal to 225 for whatever reason. We're not going to reject, we're not going to reject. There is sufficient evidence. If you do have sufficient evidence, then you would reject the null. Okay? Let's check that answer just for goodwill. Okay. All right, moving on. This seems to be basically the same question as before, different significance level. Okay, this one's a little bit different. So we have data here now. So this isn't just of an output. So we're going to walk through this one. Okay, so again, I know that this is not the right one because it has doesn't have an equal sign where the null hypothesis is. So I'm going to pick between A, C, and D. So I'm just going to try and find the claim really quickly. The significance level test to claim that with garlic treatment, the mean change in LDL cholesterol is greater than zero. Greater than zero. Okay, so it's D. Well done. Go. Okay, determine the test statistic. I have summary data here, so this is similar to a previous tutorial, but we're going to go through it again. So I'm going to go down to t-stats, one sample with summary. I know that the mean is 0.4. Know that the standard deviation is 24.9. And I know that the sample size is 81. Okay. And what is my claim? I am claiming that it is greater than. That's very important. That changes it from a two-tailed test to a one-tailed test. Okay, here we go. Here's my output. It's asking me for the test statistic, t-stat. I'm going to round it to 2 decimal places, 1.14. Answer. Good job. Okay. Determine the p-value. 0.44. 3 decimal places. 0.442. Check answer. Well done again. Okay. Now state the final conclusion that addresses the original claim. So I know that my p-value was 0.44. My significance level was set at 0.05. I would only reject the null hypothesis if my p-value had gone below my significance level. Here you can see that is obviously much higher than my significance level. So I am going to say that I'm going to fail to reject the null hypothesis. There is not sufficient evidence to conclude that the mean population of changes is greater than 0. So that's my null hypothesis. So I say I failed to reject the null because there's not enough evidence to support that my null hypothesis is indeed true. And there you go. Okay, so I think that is probably good enough. So the rest of these questions are going to be very similar. Let me just look through, make sure there's no other weird ones. Okay, if you have data like this can get a little confusing. So now you have data. Okay, we're going to do this one really quick then. All right, so now we're basically doing the same thing that we did before, but we went from just using a t-statistic to using an output to using a summary to now we have actual data. So I don't even really need to look at the data yet. I'm just going to open it in StatCrunch to start. It's going to open up into a different StatCrunch for some reason. I'm just going to drag it over here. Here's all my data. I don't have to enter it in manually, which is great. I'm going to determine what my alternative hypothesis is. I know it's not this one because it doesn't have an equal sign for the null hypothesis. Assume that a sample random, blah, blah, blah. Use the diastolic measurements for adult males, the same kind, blah, blah, blah. Suppose the diastolic blood pressure test is considered to be hypertension. The adult males, I'm overread it somewhere. Use the diastolic blood pressure measurements. Adult males listed in accompanying data table and test to claim that adult population has a mean diastolic pressure less than 90. Less than 90. Check answer. Great. Okay, identify the value of the test statistic. Okay, now I'm going to basically do what I did before. I'm going to go into stat, t-stats, one sample, but this time I'm going to do with data. I'm going to put over bar 1 to the right side. I'm going to make sure that my hypothesis is less than, and this should be 90. If it'll let me change it, it should. Oh yeah, I have to change this. Oops. A little tricky, not very intuitive there, but nevertheless I did it right after a little tinkering. Okay, I think that's all I need. I'm going to click compute. Okay, big differences here, very high t-test. Okay, so identify the value of the test statistic. Negative 21, 2 decimal places, 0.41. Okay, check answer. Fantastic. Identify the p-value. When it rounds to 3 decimal places, you can pretty much put in whatever you want. I'm just going to do 0.001. You can even probably put in 0.000. As you can see here, it goes really, really small. State the conclusion about the null hypothesis as well as the final conclusion that addresses the original claim. So we're just going to go between, we're going to reject the null because our p-value is less than our significance level of 0.1. So as we can see, p-value, very small, significance level 0.1. Small number is lower than this number. Therefore, we're going to reject the null hypothesis. There is not sufficient evidence. Nope, we're not going to say that because we do have evidence here based off this experiment that there is sufficient evidence to support the claim that the adult female population has a mean diastolic blood pressure level less than 90 milligrams. Oh, millimeters Hg. Okay, and there you have it. And remember, yep, okay, oh, this one, yep, check answer. Great job. Okay. So hopefully this was, oh, there's one more here. Based on the result, can we conclude that none of the adult females in the sample have hypertension? Ooh, a little tricky. A little tricky. This one is kind of very, not so subjective, but this is where statisticians can really kind of get into the thick of it. Yes, because, no, because the conclusion about the null hypothesis is just the mean population, not the population. This is a sample, so it wouldn't be E. We're not going to generalize everybody in the data just because of the average. So we're going to say no because the conclusion about the null hypothesis addresses the mean of the sample, not individuals. Oh, you gotta be kidding me. Carefully review the previous conclusion. I mean, hypertension is not necessarily 90. Well, if it's over that, this is diastolic. Okay, this is where you actually have to know a little bit about blood pressure, I guess. I would say then we have to go with this, I guess. Oh my god. Okay, no, because the conclusion about the null hypothesis addressed the mean. This is where it gets frustrating. No, because HO is not rejected. Based on the result, can we conclude that none of the adult females in the sample have hypertension? I'm going to say no. Does I want this one? Oh, you gotta be kidding me. Okay, so I was right in the first one, but it was being nitpicky between sample. Let's look at that again. It's being nitpicky between sample or population. This isn't really a population. I didn't really read this too carefully. This is where you have to really read this carefully. Well, if you run into this problem and you feel like it's wrong, go up here, ask your instructor, and I'll probably give you the point, okay? Because I do not like that. Okay, sounds good. If you have any questions, feel free to reach out. Hope this helped. Bye.